Welcome back, everybody. Today we're going to be having some fun because I'm going to be breaking some ratchet straps. I'm going to be testing the myth that putting a twist in the ratchet strap decreases its load capacity. Everything from one twist, multiple twists, and even knots. And we're going to find out how this affects the strap. I have found that the strap being twisted doesn't flap or vibrate as you're traveling down the road and basically singing you a song. It also helps with keeping the wear and tear off the straps as it's vibrating, or protects the object that you're strapping down from the vibration, which could cause some cosmetic damage to the load. So in the last video, I put a twist in the ratchet strap, and when I did that, I was flooded with comments saying that I had reduced the ratchet strap's capacity up to 50%. So I want to take it upon myself to do some testing and find out some answers, and I hope you guys will join me. Under normal conditions, a twisted strap probably isn't going to do much harm, but when a load shifts, when you hit a big pothole or get in a car accident, that could put the strap in a lot more stress, causing it to break. Here's my plan to create a controlled car accident. I'll start with a heavy-duty surface. From there, I'm going to need 2 secure points to mount the ratchet strap to. To simulate the load shifting, I need to push on the strap hard enough until it breaks. Instead of destroying my trailer, we're going to use this big giant piece of plate steel. Here's what we're going to be using to test with. The standard 2-inch ratchet strap. These straps are rated at 3,333 pounds working limit and a 10,000 pound braking strength. So we're going to be stretching this thing to roughly 10,000 pounds. And in here is our air jack, which is going to be the load. And this will give us the added force we need to be able to snap the strap. So I could operate this jack with this handle, but this is going to potentially put me in harm's way when the strap breaks. So I'm going to use the air over hydraulic feature, and I can operate it from a safe distance and not get slapped in the face with the ratchet strap. I have to figure out some way to get this mounted in the center of the table. So if I bolt this down to a block, I can tack weld this to the table. I can bolt this to the top there. That'll work good. One problem that I see with this jack is, obviously I don't want to be putting the ratchet strap straight over this ram right there because it'll just poke a hole right through it. So I need to make something smooth that makes a nice smooth transition over the top so the strap doesn't break. I was going to weld this piece of metal directly to the ram, but I decided against it just in case I have to replace the ram during the test. And this leaves my options open a little bit later to be able to use the ram for another project down the road. So a bolt-in connection seemed like the best thing to do. I'll probably never use this component again, so I'm just using some scrap from around the shop to make it. This component's probably going to take quite a bit of force. I'm doing it the Fireball fashion and building this a little bit overkill. The hydraulic ram I'm using is capable of producing 8 tons of force. That's almost double what the capacity of the ratchet strap can hold. I'm expecting this ram to generate some pretty big explosions. Oh yeah, that's better. So as the tension in the strap may be greater to one side or the other, this can compensate and keep the ram straight. I'm gonna weld the D-rings down. This is probably the most important part. These cannot come off. So I'm gonna weld them good and strong. So we have our anchors ready to go on each side of the trailer that should be strong enough to hold the strap, I hope. This is the tool we're gonna use to read the forces involved. And this is just a meter, and we're gonna strap one end to the shackle and the other end to the ratchet strap. And we're gonna pull away, and then we're gonna be able to read what's going on the scale and find out if this myth is true or not. Now let's put the strap on and break something. The first thing we want to do is just do a control test that we're going to base every measurement off of. Straight up break the strap with no twist in it. Oh man, I cannot get any more clicks than that. This is 655 kilograms, which is 1,461 pounds of pull strength. And that's the most I could do with just the handle. Listen to that. Bong. So I think we're ready for the first test. I have to admit, I'm pretty scared. This is extremely dangerous, and don't do this at home. So I'm expecting a huge explosion off of these things. So let's take about 20 steps back, and I have a remote switch back there. So let's get to a safe distance and break something. I'm hiding behind the forklift. In 3, 2, 1, go. 1,500 kilo, 2,500, 4,000. Why? Holy crap. That was a huge concussion when that strap blew up. I could feel it in my chest when that thing exploded. Let's check out the strap. Look at that. It broke right here at the spindle where it wraps around the joint, and it's like it friction welded itself to each other. Huh, quite impressive. Here's where the other end of the strap landed. Oh, wow, that is incredible. Where it went over the top, it's like melted. That's pretty crazy. There's the other end. It's warm. That's pretty interesting. And we're about 20 feet away from the rig. So that thing has some serious explosive power behind it. That strap is moving so fast, I want to see it in slow motion. So let's check the meter to see where this broke at, and that will be our target for the other straps. 4,279 kilograms. That's 9,433 pounds of force that it took to break that flat strap with 0 twist in it. I want to test the ratchet straps when they get wet, so I'm going to submerge these in water. This is going to simulate driving in rainy conditions or if they get soaked. And then at the end of the test, we can test them all out. Okay, we'll let that soak there for a bit. The next strap I'm going to test is the half twist. And this is what I like to do to keep the wind from wreaking havoc on the strap and the load, just like that. So I can see the strap wanting to twist right there with a full twist in it when it's super tight. Let's see if that's a stress concentration. All right, let's see what happens. 3, 2, 1, here we go. 1,500, 3,000 kilograms. Coming up on 4,000. Wow. Oh, geez. That looked like it was exactly the same strength to me as the control. It might even been stronger. So let's take a look at where it broke. Broke in the same exact spot as the flat strap, right there at the spool. Let's see where the other side landed. Oh, look, it landed all the way over here again. It's hot. There is warmth to the strap. That's pretty incredible. Where it was twisted on itself, it did get hot there. That ended up being 4,375 kilograms. That's 9,645 pounds. With the twist in the strap, that didn't diminish the load rating at all, which is quite surprising. How many twists does it take to reduce the strap by 50%? We're gonna find out. Let's do 4. See what happens. What's interesting is it wants to curl over on itself at the load up here. I think it looks good. Okay, let's test the 4 twist ratchet strap. Here we go. 1,500. 4,000 kilograms. Oh, geez, holy moly. I'm noticing a pattern, look at that. It got so hot right there, it melted itself together. That is impressive. This is extreme. That got up to like 4,200 kilograms, which is right where the control was. And that had 4 twists in it. That's 9,270 pounds. That's barely a reduction from the control. So this myth is not looking very promising for the twists in your straps. That is a serious result. I want to test putting as many twists in the strap as physically possible. If that's 10 or 15, I don't know. We're going to count. There's 1, 2, 3, 4, 5. There's 10. Yes. So each side has 10 twists in it. This is ridiculous. We're just gonna roll it up. Who cares? 10 twist strap test. Here we go. 3, 2, 1. 1,500. 3,000 kilograms. 3,500. Oh, hey, man, that has some force. Woohoo! I jump every time when that happens. It looked like to me it was like 3,500 kilograms, which is pretty amazing with 10 twists in there. Whew, let's see where it failed. Yep, right there where every other one has failed. 10 twists in the strap gave us a number of 3,492 kilograms, which is 7,698 pounds, which is a pretty good reduction from the control, but it's still pretty high with 10 twists in there. So still not even close to the 50% that the internet says it is. This is still a good result. I want to continue testing till we see that result of the 50% reduction. So I want to try a knot first. That looks like a good knot. These are like impossible to get out too. If you have, after looking at that, that is a pretty high concentration, having all the strap come to that narrow point right there. Knot test in 3, 2, 1, go. 1,000 kilograms. Ooh, hearing noises. Oh, that was a result. Woo, that only got to maybe 1,700 kilograms of force. That's what I wanted to see. Look at that, it broke right at the knot. And it's melted. Oh, that's so cool. $1,630 kilograms, 3,593 pounds with a knot in it. One knot has reduced the capacity by over 50%. Knots are bad. So now I want to test the strap that's been soaking in the water bucket for a few hours. So let's test that. Anytime explosions are involved, things are fun. 3, 2, 1, go. Wow, that was pretty intense. That looked about the same, around 4,000 kilograms. But let's take a look at what broke. Yep, right here at the ratchet strap. Ooh, and it's even warm to the touch. Man, that's incredible. What I just noticed, this 4,000 pound piece of steel sitting on the stand has moved. It is literally twisted and shifted. That's how much force these straps are applying to this table when that releases all its tension. Learn something new every day. Pretty amazing. Let's check the footage. So that landed us at 4,013 kilograms with a wet strap, which is 8,847. So a slight reduction in performance from the wet strap to the dry strap, but not enough to worry about. Pretty good results there. Look at all the straps that we broke. Got a strap graveyard. Man, seeing a twist in a ratchet strap, I'm not really too concerned about its load rating being decreased, but I definitely can't recommend you guys putting twists in the straps, even though I'm probably still gonna do it just to keep the wind vibration down. But I'm definitely not gonna put knots in my straps. And even in wet conditions, I'm not worried about the strap losing any of its capacity, which I find extremely valuable. So I hope you guys found all this information useful too, and I'll see you guys on the next one. Ding, 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 ding. Photo time. Freeze frame.